Alright guys, so I want to take a look at section 4.1 that starts on page 274, talking about linear functions. Alright, so what's going on is, remember we have a whole bunch of different kinds of functions that we saw before in the library of functions. We're going to focus in a little bit here on functions that are, you can draw them with using just a straight line, no curves or anything. That's what linear means, and you can see the word line in the name. So linear functions. Linear functions, one of the most useful forms to write a linear function is like this. F of x equals mx plus b, where m is a number and b is a number. The name of this kind of form, it's called slope-intercept form. And the reason why it's called slope-intercept form is because this number m is the slope of the line. So this is the slope. So this is the slope. And this number b is the y-intercept. So b is the y-intercept. What do I mean by slope? Now, just to kind of zoom in on kind of, or think a little bit more about the word slope. The slope, we may remember from before, the slope can be written as, so m is the rise over the run. The rise over the run. Or another way to say that is the change in y. So that's the change in y over the change in x. Now, what does that mean? I will show us in this next example. Okay, so example one, look at example number one. Example number one says here's the function f of x equals negative 3x plus 7, and we're asked to graph the function. Okay, so if we look a little bit closer here, so the slope of this is a minus 3, so that's our slope. And our y-intercept is a plus 7, so that's our y-intercept. Y-intercept. So what does that mean? If we look at the graph down here, when it has a y-intercept of plus 7, what that means is it's going to cross the y-axis at a plus 7. So that means we go up 7, 1, 2, 3, 4, 5, 6, 7, and the graph is going to cross right there. Okay? That's one point we know on the graph, is a point 0, 7, because it has that as the b number right there. And then the slope is a minus 3. Now what does that mean? We look a little closer to slope. Slope is m. Now it's always nice to write the slope as a fraction. So if we write negative 3 as a fraction, we could write that as, so it's negative 3, but we can write that as negative 3 over 1. Keep the negative sign with the number on top. Okay? So that's a negative 3 over 1. Remember before we said that was rise over run. And here's what that means. Negative 3 is how we, like, if we're going to go from one point right here to the next point on the line, the way we move there, this is like directions for how we go from this point to the next point. The rise, or the up and down part of it, is minus 3. And then the run, or the left and right piece of it, is 1. So here's how that works. From this point, we're going to go, the vertical movement we're going to make is a minus 3. So we're going to go down 3. So 1, 2, 3 to here. We're going to go down 3 to right here. And then we're going to go, we always go to the right when we go over. So we're going to go over 1. So over that way, 1. So we're going to go down 3, 1, 2, 3, over 1 to right here. That's the next point on the graph. And we can keep on doing this forever. We can go down 1, 2, 3, over 1. There we go. Do it again. 1, 2, 3, over 1. There we go. Notice they all fit, they all fall in this nice straight line here. And so we can just connect all the dots. And there's our line. Okay, so that's how we graph a line when we're given the linear function in slope-intercept form. Alright? One last thing I want to look at about these lines is there's some terms we have. Remember before how we had that the graph could be increasing or decreasing or constant. And so the way to tell if a linear function is doing any of those things is by looking at the slope. And the rules are right here. A linear function is increasing if the slope is positive. Right? It's decreasing if the slope is negative, and it's constant if the slope is 0. And so here's what I mean. Okay. Example number 3 in the book shows a couple of things here. And so f of x for a, so f of x is 5x minus 2. Remember, the slope is this number with the x right there, and it's a 5. It's positive, so this one would be increasing. This one, g of x is negative 2x plus 8. Let's look at the slope. It's negative, so this will be decreasing. This one, s of t equals 3/4 t minus 4. The 3/4 always kind of throws people for a loop, but remember, all we're looking at is it positive or negative? This is a positive 3/4, so it'll be increasing. The difference would be, maybe it won't be as steep as maybe this one up here. This one might be, a line that kind of goes up very fast, and this one might be a line that goes up a little bit slower, maybe not as steep of a line. And then over here, h of z equals 7. That looks like the constant function, where it's just like f of x equals a number. And the reason why it works is because another way to write this would be like to say h of z equals 0 z's plus 7. So if you write it like this, the slope now, the number with the z is now 0. So we've got 0 z's plus 7, and we said if the slope was 0, then it was a constant. So there you go. That's how that works. All right? Cool.